So we're continuing with our pattern tables today. We're going to add one more element to it. This is our third thing that we're learning about patterns and pattern tables. We have one more thing, one more lesson of new stuff, and then we'll kind of start putting it all together tomorrow. But anyway, so today we're going to look at pattern tables, and we're going to turn those pattern tables now into graphs using those X and Y coordinates and our X and Y grid. Okay, so one quick thing before we get started. Okay, so there's two ways that a pattern table can be set up. It can be set up in the vertical fashion, like the table here on the left, or it can be in the horizontal fashion. We saw most of our ones yesterday were in horizontal fashion, like the one over here on the right. Okay, now the important thing, and this is super duper important, like so important, guys, so please pay attention. When it's set up in the vertical fashion on the left, the left-hand column is always the X value, and the right-hand column is always the Y value. So when we look at rules and like patterns, we always, when it's vertical, we go from left to right. So we look at the X, and then we go to the Y to figure out the rule. So if this were like 2, sorry, my pen's not engaged right now. If this was an X value of 2 and a Y value of 4, we'd be saying, oh, what happens to 2 to get 4? And it could be plus 2 or it could be times 2. We don't know because I don't have any other values in here. But it's always looking from the left to the right when we figure out those patterns for a table that's in vertical fashion. When it's in horizontal fashion, we're always looking at the X's on the top, Y's on the bottom. So once again, if this were 2, and this were 4, we'd be looking at from top to bottom. So I'll do another one so we can actually tell. Yes, so 2 times 2 is 4, 4 times 2 is 8. So it's going from top to bottom to figure out that rule or that connection between the two values. Okay, so that is super duper important so that you plot your points correctly on your graph, because if you have them flip-flopped, you're not going to have a graph that has everything plotted in the right place. Okay, so let's look at this. So a lot of my tables are going to be ones I used yesterday because we already talked about them. So now I can just move on to this new thing of plotting the information. So this is the Jack and Javier game from yesterday. So yesterday Jack was represented by the variable of J. He still is. The rule is still J minus 4, gives you the bottom part from top to bottom. Doesn't matter. What we're really looking at today is, hey, the top row is X, the bottom row is Y, and now we're going to plot these points. Okay, so because there is a rule, you're going to see something really cool happen. Every time there's a consistent rule, you're going to see something really cool happen with your graph as you plot the points. So I need to put a point at 17, 13 because it's X before Y. So when I would write out those ordered pairs, it would be 17, 13. So I'm going to plot a point there. I'm going to plot a point at 20, 16, 25, 21, and 32, 28. Now, this coordinate grid that I have over here, I already put numbers on it. And on my x-axis, I have it from 0 to 4, but there's a line in between. So it's really counting by 2. So this is 0, the one in the middle is 2, then it's 4, 6, 8, 10, 12, and so on. Same thing on the y-axis going up. Okay, so when I go to 17, 13, it's 17 on the X. So when I look at this, I don't have a 17. I know this is 16. I know this is 18. So 17 is going to be right in the middle. And then I have to go up to 13. So here's my 17. I'm just going to mark it for a second. Okay, and then I have to go to 13. So 13, this is 12. This is 14. So 13 is in the middle. So I'm coming over. And it's going to be right in the middle of that white space. So that's where 1713 lives, right in the middle of that white space. And we did talk about before we left school, hey, sometimes our points do exist in the middle of the white space. Okay, so for my next one, I have 2016. So 20 is on my X. 16 is exactly on my Y. So, oops, hold on, because my numbers are a little off over here. So 0, 2, 4, 6, 8, 10, 12, 14, 16. Okay, there's 16. Okay, so 2016, it's right there. And then I have 25, 21. So 24 is here, 26 is there, so 25 is in the middle, and 21 is going to be right there. So it's existing in that white space right there. And then I have 32, 28. So 32 and 28. I think that's 28. Let me count it out. 20, 22, 24, 26, 28. So 32, 28. Okay, so what do you notice about all those points? Well, if you don't see it, I will show you. I'm going to try to take my hand here and do this. These points connect exactly. Oops, I missed it a little bit. Hold on, I'll fix that. Okay, oops, hold on. Technology difficulty. They are existing in a perfect line. When there is a consistent rule, your points will always lie on a perfect line. You can shoot right through them and it doesn't zigzag down or up or anywhere else. It just goes straight diagonal in a direction. So it can go diagonal up, it can go diagonal down, like this way you could have a line, but your points will always sit perfectly in a line. Okay, so let's look at another example. This is also from yesterday, Sheena and Julie. Okay, so Sheena's information is on the top, so she's going to be the X. So let me get my marker here. She's going to be the X. Julie's going to be the Y. The rule is still Sheena divide by 2. Since there is a rule, our points should be in a perfect line. So when I go across here, I have Sheena at 6, Julie at 3. So that would be right there, 6, 3, because it's 0, 1, 2, 3. Sometimes if I don't have space, I don't have to write all the numbers, but as long as I can figure out what number goes in between, it's totally okay. So then I have 12, 6. So 12 on the X, 6 on the Y, boom, right there. 14 on the X, 7, right there, and then 20 and 10. So if I look at this, I'm going to hand draw it this time. And see how I can do here. Okay, so boom, 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 perfect. Line goes off forever. Okay, so I can literally check and I can put more points on here that would be consistent with Sheena and Jolie's game and their role. So let me plot another point here that would work. Let's do this one right here. Right there. That's at 16, 8. 16, 8. 16 divided by 2 is 8. Boom, it matches the pattern. Let's try another one here. How about this one right here? That's at 8, 4. 8, 4. 8 divided by 2 is 4. Boom. That would also be a part of Sheena and Julie's math game that they were playing yesterday because it matches the rule. Okay, so there's a lot more points than the ones that you actually plot on a graph that show the rule. It's just whenever you plot out your points for the rule, it will make that consistent line. Okay, so now we have another one that I already did for you just to kind of show you that line. So I plotted at 3, 7, 4, 8, 5, 9. And then my line shoots right through them. If I continue that line, and my hand draw and continue it, we can see that 2, 6 would be on that, 1, 5, and 0, 4, because 2 plus 4 is 6, 1 plus 4 is 5, 0 plus 4 is 4. So all these points would also be a part of this rule or this pattern. So this isn't that complicated, guys. Okay, so I'm going to go dual screen here. Whoops, wrong thing. I'm going to go dual screen here if I can get this to happen. Okay, and in order to do this next part with you. Okay, so now we're going to kind of put it all together. And I'm going to show you, I already did part of this. So having a rule, finishing out the pattern table, then graphing it. So it says create a numerical pattern that follows the rule plus or add 3. So pattern 1, that's what I did. I started at 0 and I'm adding 3 each time. So 3, 6, 9, 12. The second numerical pattern followed the rule of subtract 3. So it started at 15, subtract 3 to get 12, then 9, 6, and 3. Then I wrote the ordered pairs for those corresponding terms. So 0 and 15 are corresponding terms, are the first terms, they go together. 3 and 12 go together, 6 and 9, 9 and 6, and 12 and 3. Corresponding terms means the first 2 terms are corresponding terms because they're the first ones. The second 2 in both sequences, they're corresponding terms. So it's just the matchup of the 2 terms, the first and the first, the second and the second, the third and the third. So I can make ordered pairs out of those. And now that I did that, I can graph them. So over here on the right, I have my graph with the x-axis and the y-axis. There's an interval of 2 because the direction said use an interval of 2. So I started at the origin. Well, there's one of those vocab words from before we left school. So origin is where the beginning exists. So 0, 0 is right there. Okay. And then I just went, and every line I jumped up by 2. So 2, 4, 6, 8, 10, the whole way to 20. And then I did the same thing going up the y-axis. Okay. So now I can plot. So my very first point, I'm going to take that point out there at 0, 0 because I just wanted to remind you of, sorry about my phone, guys. I just wanted to remind you of that vocab word of origin. Okay, so my first point that I'm going to plot is at 0, 15. So 0, 15, oh, it's going to be right between 14 and 16. And then I have 3, 12. So 3 is between 2 and 4, and 12 right there. You can already tell your line is going to be sloping a different direction this time. 6, 9, 9, 6, and 12, 3. So instead of shooting up and to the right, this time our line is coming down, freehanding it, sorry guys, down to the right, okay, and shooting off of our coordinate grid that direction. So having all those points plotted to show that pattern, and it pops right out because it makes that perfect line. Okay, I'm going to go back to single page. Okay, I have a couple more things to show you. Okay, so in this one, this is something I would have had you do in class on paper, but that's okay. So every once in a while, I want you to pause. I want you to think about where things would go before I show you, okay, because I'm going to kind of keep going with it. So over here at the left, I have a table that has the X's and the Y's, and then just writing out my ordered pairs, remembering my comma and my parentheses because it's not an ordered pair without them, and then plotting those points. So moving over and plotting them down. Now this time, because they have letters, I'm going to label them. So at 5, 6, I have point M. At 7, 8, I have N. At 9, 10, O. And then P is at 11, 12. Okay, so it says plot points M through P and draw a line M through P. So I'm going to change that to black. Oops, that's an M. And go boo boo. That was horrible. Sorry about that, guys. Let me try again. Ooh, that's a little better. Okay, freehand is a little bit hard. Okay, and it's like, and then the next question down here at the bottom says list the coordinates of 2 other points that are on line MP, because this is line MP that would go on forever. So when I look at this, I can look at this line and say, oh, hey, look. I can say, oh, this point's on it, and also this one. So another 2 would be 6, 7, and another one would be 10, 11. And if I look at this from 5 to 6, this is all plus 1, plus 1, plus 1, plus 1. And these two follow that rule, plus 1. Okay. Okay, so I think you guys are probably getting the idea of that. So I'm going to stop there. There is a practice for you to do. If you have any questions, you can send me an email or check into my office hours any day at 10.